Hey, it's me again, Jimmy. Now, with a title like De-Energize and Test Before You Touch, you probably have a good idea what this segment's about. We're going to be talking about...
Jimmy, you see my meter anywhere?
Hey, Carl.
Hey, how you
No,
doing?
actually, I haven't. You know what? I wanted you to help me demonstrate Test Before You Touch.
You're gonna need a meter for that, and Max borrowed mine and never returned it.
Okay, well, you know what? Maybe I'll get Max to help with the demonstration.
No can do. He's off today. Dental appointment or something. I gotta go to work.
Wait a minute. How are you going to do your job without your meter?
Oh, that shouldn't be a problem. Most circuits are locked out and tagged.
Okay, whoa, wait just a minute there.
What?
Never assume that a circuit is dead, even if it is locked out and tagged. You know what, Carl? Why don't you take a couple of minutes and let's talk about Test Before
I don't
Touch.
have a couple of minutes. Max is off. We're
Give me
short-staffed.
just 5 minutes.
All right, 5 minutes.
Okay. Now, no matter where you're working, whether it's in a large manufacturing plant or on a small installation, when the job involves equipment that could be energized, always test before you touch. Electrical measurements are a routine part of the job for many electricians and maintenance technicians. But if your meter is malfunctioning or it isn't used properly, you could be seriously injured or even killed.
Are you serious?
Seriously. Now, when you take electrical measurements, the system needs to be energized. Your meter and test leads are connected to a source of energy, and mistakes can have disastrous consequences, such as electrocution from contact with exposed live connections at the test probes or plugs. You can be electrocuted from conductive paths caused by moisture or contaminants. Should a test lead become dislodged and come in contact with a conductive object, an arc could occur. And when the leads of a meter intended to measure voltage are inadvertently plugged into the jacks for measuring current, fire or an explosion can happen. The same disastrous results can occur should voltage transients break down the insulation in the meter or in the leads.
Man, I had no idea.
You know, you can find out a lot of this information on the IEC standard.
The IEC. Oh, the 61010-1, the International Standard for Test Equipment Safety?
That's right. Now, you should select a meter with a safety rating that exceeds requirements for both the category and the voltage. For most industrial work, 600 volt Cat 3 will be the minimum acceptable.
Max had a brand new meter, 1000 volt category 3 and 600 volt category 4.
Really? So why was he borrowing one from you?
Oh, he lent it out to somebody and they never returned it.
Okay, well, whichever meter you order, make sure that it has a number of safety features, like shrouded test lead plugs that limit exposed conductive parts, even when not inserted. Audible alarms that sound when your test lead connections don't agree with the switch setting. High interrupting fuses in current measuring circuits. These help prevent destructive current if the meter isn't connected properly. And look for rugged cases. Most meters get banged around in the field, and you're going to want something that's going to keep working reliably. You want hangers on the meter case. You need both hands to make measurements without having to hold your meter. And the same with the probes. You want test probe clips to make it easier to access the test point safely. And like we just talked about, you want your meter to have higher safety category ratings and a listing by a nationally recognized testing laboratory, like UL, to ensure that your meter meets minimum safety standards. And choose a quality meter from one of the well-known manufacturers. And don't go for the bargain price meters. Most of them aren't as well made, they don't have all the features you need, and they may be dangerous in an industrial environment. Your safety depends on using the proper test equipment. And don't assume that your meter's working correctly. Inspect your meters before each use. If you're working with a defective piece of equipment, you're working without protection. Okay, let's get to the test before you touch.
I know the mantra. Every person tests every conductor every time for absence of current before they touch it.
Very nice.
Thank you. Okay, off to work.
No, wait a minute.
You're not done just yet.
There's de-energize the circuit, lock out the circuit, test the circuit, and verify the testing device. Case closed, the end.
And before you get started,
You slip on your voltage-rated gloves. It's an OSHA mandate.
and you de-energize the circuit by determining all possible sources of electrical supply to that specific piece of equipment that you're working on.
That means break the connection to the source, Make sure there are no backfeeds.
And if it's reasonably possible the de-energized circuits could become re-energized by another source, they must be grounded before you touch them.
So what do you do after you remove the load from the circuit?
Open the disconnecting device for each circuit.
Way to go, Carl. And last, you got to visually verify that all blades of the disconnecting device are fully open, or that draw-out type circuit breakers are completely drawn out to the disconnect position. So, what about testing the circuit?
You need to test each phase conductor or circuit part to verify that they're de-energized.
And you need to test them phase to phase and phase to ground. Before and after each test, determine that the voltage meter is operating satisfactorily.
How's that?
Test something you know the voltage of to make sure that the meter is operating correctly. Then, test the de-energized circuit, and then retest your meter.
Got it. The important thing is to test for a known voltage before you start to work.
Now that covers de-energizing.
I'm going to take a wild guess and say lockout is next.
Bingo.
That's a tough one. Lockout is different in almost every situation.
No, you're right. But basically it means that you apply a lockout device to the circuit. The object is to create an electrically safe work condition. And what's last?
Never assume.
Right.
All right, Jimmy. Got to get back to work.
Okay, wait. What about your meter?
Oh, I think I got one in the truck.